This is Geometry Lesson 8.7, Special Right Triangles, Part 2. So in Part 1, we covered the 45, 45, 90 triangles with our x radical 2 setup and pattern on the side lengths there, very specific type of triangle. And today, if you flip that notes page over, we're going to just be looking at 30, 60, 90 triangles. So this will work similarly. Some of the math that we have to do is the same. We're going to be dealing with a lot of square roots. And so a lot of the trouble in this section is just remembering or learning how to multiply, divide, and simplify radicals or square roots. And that's where we run into some of the trouble. So let's walk through this together, and we will continue in class practicing our algebra skill of simplifying and multiplying square roots and radicals. And as we practice this over the next couple of days, this will get easier and easier as we go, but certainly needs practice to master this. So 30, 60, 90 triangles. I've got the picture set up right here for you. They're obviously not going to work exactly the same as a 45, 45, 90 triangle because they're different. And so the length of the shorter leg, so we've got two legs here in a 30, 60, 90 triangle. The shorter leg is going to be represented by x. The length of the longer leg is x radical 3. And the length of the hypotenuse is 2x. Okay, so again, this is only going to work when we have a right triangle with a 30 and a 60. Now, just remember, as you look down to these ones, we don't need the third angle given to us. We know that the sum of the interior angles of a triangle is 180. So if I have a 90 and a 30, I know this one's 60. If I have a 90 and a 60, I know this one's 30 because they're going to have to add up to 180. All right, so the three sides here are x, 2x, and then the weird one is x radical 3. Part of this, the struggle on this section, is just remembering which one goes where. All right, so the way that I remember it, and this may work for you, may not, is that x, which out of 2x and x radical 3, to me appears to be the smallest, and it is going to be the smallest side of this triangle, is going to be across from the smallest angle. Okay, it's all about what it's across from, because remember, these angles, how big or small they are, form the opposite side across the triangle. So a small angle here projects out and creates a small side here. So for me, I always can remember that x is across from 30. 2x appears to be the biggest. X radical 3 is just kind of a weird looking one, but 2x is the biggest side. Okay, you're doubling the size of this one. And so the biggest side of a right triangle is always across from the 90. So my 2x is across from the 90. So smallest side represented by x across from the 30. Biggest side across from the 90 is 2x. And then that leaves us our odd side, which is across from the 60. And again, if I have two of these sides, I can always use a squared plus b squared equals c squared, because it's a right triangle. That will always work for any right triangle. But these special triangles allow us to find missing sides when we're only given one side, where a Pythagorean theorem would not be an option. So yesterday we looked at the 45, 45, 90s, and those were isosceles, right? So we had two equal sides. So it probably seemed a little different, where you could have used Pythagorean theorem if you really wanted to fall back on it, because if we have one of these sides, which are the legs, we actually have both because they're equal. So you may have only been given one piece of information, but you were quickly able to come up with two sides. And to find the third side, you could have certainly used Pythagorean theorem to get there. So that's not going to be the case here on the 30, 60, 90s. Sometimes if we're given just x or 2x, it's easy to find the other one, and then we just have to deal with x radical 3. And you could go back to Pythagorean theorem once you've got two of the sides. But we want to get a little faster with these. And again, x radical 3 is across from 60. So we're going to recognize this pattern, the 45, 45, 90 pattern, and be able to quickly kind of fill in the sides here based on this information that we've got. So as we look at this first example, we want to identify where all of our sides are located. The one that's given to us is across from the 60. And so remember, that's our x radical 3 spot. All right. If we want to, we can go around here and label. And what I'm going to do to try and make this less confusing, in this picture we have an x and a y in those spots, meaning go find them. But when we start calling these things x and x radical 3, these variables in the picture can make that sometimes seem a little confusing for students. So let's just cross those out so we're not dealing with extra variables. And we're just going to go ahead and find all our missing sides here. So this is our x radical 3. It's across from 60. Across from the 90 is our 2x. And across this would be 30. Across from 30 would be our x. So let's look at the information that we've got. And we basically always want to find x. Once we know what x is, we can put it across from 30. We can double it to put it across from the hypotenuse. And if we didn't have the side across from the 60, we just take whatever x is and multiply it by radical 3. And if it's a whole number, it just gets attached to it. So in this case, you can see the x radical 3 side is 2 radical 3. So 2 is in the x position, which means x is 2. So I can go ahead and put that up here. This side is going to be 2, x equals 2. And therefore, the side that's the hypotenuse across from the 90 is always twice the size of that. So once you have x, we know the hypotenuse is 2x. So we're just going to plug that in and multiply. This side is going to be 4. So I have sides of 2. Let's go ahead and box these in so when we look back, we can see clearly what we've got. We've got a side of 2, a side of 4, and a side of 2 radical 3. That's a very basic 30, 60, 90 triangle right there. Whole number for x, you double it for the hypotenuse, you take that number and you attach it to radical 3 on the side across from 60. Okay, so for a basic problem, you kind of just fill it in like we did there. But when we deal with some other numbers that are in spots where we want to see a square root and maybe we don't have that, or we put a square root in one of these spots, we need our algebra skills of multiplying and simplifying square roots to be at the top of their game. So we're going to keep practicing that. All right, so in the second problem, you got to recognize what you have. Okay, that's across from 90. This is the 2x position. All right, so this is a pretty nice number, right? We don't have a square root that's given to us. You can see on the next problem, we're also given the hypotenuse, but in a square root form. So that makes things more difficult. But in this section, we've got the 16 on the hypotenuse. That's 2x, so that's twice the size of whatever x is. X is going to be across from the 30. This is going to be your x radical 3. That's across from 60. So if 2x is 16, x is going to be half the size. The hypotenuse is always double the size of the shorter leg across from 30. So if this is 16, I know that this side is 8. And once I know what x is, the side across from 60 is nice and easy. I just take 8 and plug it in for x. So this side is going to be 8 radical 3. So I have sides of 8, 16, and 8 radical 3. Over here I had 2, 4, and 2 radical 3. So when we have whole numbers in here for x, these fill in rather nicely. But of course, it's not always going to be that easy. Okay, so for the next example, let's get this in focus for you. For the next example, this is not in the x radical 3 spot. So be careful. When students see this with the square root of 3, they automatically say, oh, okay, 4 must be x. But this is in the hypotenuse spot, which is the 2x spot. So 4 radical 3 is equal to 2x. So if I want to know what x is, it's going to be half the size of this. So you don't necessarily have to do this algebraically. Some of you might be able to just look at this and know what half the size of it is. You just take half of this number. In general, when we are multiplying and dividing, these square roots, if they have a coefficient in front, notice I use the word coefficient, it's just like if we had a coefficient to an x. So I can divide this by 2, I can divide this by 2, and just that front number is affected, right? We don't actually do anything with x. So if I'm dividing this by 2, these get divided. If I'm dividing this by 2, these get divided, and the square root kind of tags along like a variable would tag along in that sense. Okay, so half of 4 square root of 3 is just going to be 2 square root of 3. All right, now, so that's what x is going to equal. X equals 2 radical 3. This may even make it look more confusing than it needs to. If you just say, okay, 4 radical 3 is in the 2x spot, I need to take half of that to get the x spot. Just take half of 4, and it's 2. So across from my 30, that's where my x is going to sit. That's going to be 2 radical 3. So just like over here, if you're just looking at your x and your 2x spot, you got 2 and 4, 8 and 16, it's always double. Here I have 2 radical 3 and 4 radical 3. Smallest side, double it to get the hypotenuse. Okay, it looks a little different with the radical 3 attached to it, but you can see I'm just taking whatever that smaller leg is across from 30 and doubling it for the hypotenuse. And we work backwards to get it. So now the tricky side, cross over here. This is going to be the side that takes whatever x is and multiplies it times radical 3. So in these cases, x was a whole number. I multiplied it times radical 3, and it just attaches. So I just have 8 radical 3. Or over here, x is 2. I multiply it times radical 3. Because 2 is just a whole number, it attaches. It's 2 radical 3. In this case, my x is 2 radical 3. It's not a nice whole number. That's what x equals. But that's still what you're going to plug in for x, and that's going to get multiplied times radical 3. Okay, so this isn't going to disappear. This whole thing goes in for x. So it's going to say, I'm going to go ahead and put this in parentheses so you can clearly see what I'm plugging in. I'm putting in 2 radical 3 for x, and this radical 3 is still here. So whatever x is, it's being multiplied times radical 3. So 2 radical 3 is being multiplied by radical 3. Now, real quick review, radical 3 times radical 3 we've said is just 3. And again, the reasoning is radical 3 times radical 3 is radical 9. When you multiply two square roots, you can just multiply the numbers and they stay under the square root. But we know the square root of 9 is 3. And so we've kind of learned this quick skill of jumping past the multiplying and creating the square root of 9. And we just know that any number's square root times itself, it's just going to become the whole number that you see underneath the square root. So in this case, radical 3 times radical 3 is going to be 3. But if you did write it as 2 radical 9, because you did this times this, that's perfectly fine. This would then simplify to 2 times 3. It's perfectly fine if you just jump straight to this step, knowing that radical 3 times radical 3 is 3. And 2 times 3 then obviously is just 6. So this side length right here is going to be 6. All right, so a weird situation where the x radical 3 side is actually being represented by a whole number once we simplify, and the x and the 2x side are actually being represented by numbers that do have a radical in them. So I know this is a spot that gets very confusing for students because they always want a whole number sitting in these two spots and something with the square root here. It's just the relationship they have to each other, though, that's represented here with x radical 3 and 2x and x. So it's not going to hold true that those numbers are always going to sit in that perfect cookie cutter kind of sense. All right, so this is your x. 2x is twice the size. We double this, it's 4. All right, and then this side is always whatever x is times radical 3. In this case, it's simplified to a whole number, and that's what we've got there. All right, so for the last one, I'd like you to, if you're following along with the video, pause the video and give this a shot. Try and fill it in as much as you can, and then take a step back, replay the video, and fill in where you need to fill in. Okay, so hopefully you have tried this already. Let's walk through it and see if we can fix any mistakes you might have made. So I think sometimes a good strategy that may work for you is to label all your sides. Across from 60 is what's given to us. This is our x radical 3, so 6 is our x radical 3. 30 would be here, so across from 30, this is our x, and across from 90 is my 2x. All right, so those are my spots. Now I got to take the information that was given to me and help it to fill everything in. So basically, I need to find out what x is. So I'm going to get x by itself here in this equation that I've written, 6 equals x radical 3. Get x by itself, that's the number that'll go across from 30, and then I double it to put it over here. So let's just kind of separate this from the triangles so we just don't get too messy over here. But all I need to do here to get x by itself and find out what x is divide by radical 3. So this number already has radical 3 inside of it, right? We like when it just sits there as 8 radical 3 instead of just a 6. Okay, but something was already multiplied times radical 3 to create the 6. So in essence, what we're doing is now pulling out that radical 3. So 6 equals radical 3. We're going to divide to get x by itself. We now have the answer. This is what x is, but we've talked about a fully simplified square root does not have a square root in the denominator. So one extra step to kind of clear that out is we multiply by 1. So we haven't changed the number, but what we do is we stack up the square root in the numerator and denominator. And what that does is it just changes the bottom into a whole number, because we know radical 3 times radical 3 is whole number 3. So on the bottom, just like we did over here, radical 3 times radical 3 is radical 9, which became the 3. So here on the bottom, we're going to get a whole number 3. Here on the top, when you do a whole number times a radical, they just attach, kind of like a 6 times a x becomes 6x. 6 times radical 3 is 6 radical 3. These can be divided. And so this simplifies down. 6 divided by 3 is 2 radical 3. So 6 over radical 3 simplifies to 2 radical 3. And remember, this is what x equals. So this is my x, 2 radical 3. And if I'm going to go find my 2x, then I just double this. We know that 2x, like if we just had 2x, and we double it times 2 is 4x. Well, guess what? 2 radical 3 times 2 is just 4 radical 3. It's the same idea. Treat the square root like a variable when you have a coefficient there. 2 times 2 is 4 radical 3, just like 2 times 2 is 4x. So this side's 2 radical 3, this side's 6. We double it to get this one. It's 4 radical 3. And you may or may not have noticed, this is actually the same exact triangle. If you take a look, the hypotenuse is 4 radical 3, across from 30 is 2 radical 3, and then across from the 60 is our 6. We just started off with different information on this one, but we've actually been looking at the same exact triangle. So we will continue to practice. Most of the struggle is here, just how do we simplify when we have square roots? How do we multiply square roots? And the more we practice and brush up on those algebra skills, the easier this will get.